Hi, I'm Lori. I study the planets, our solar system, and I especially love volcanoes. And this is Ask NASA. The thing I love the most about our solar system is that it's an incredible natural laboratory. We have so many different types of objects in the solar system, from planets and moons and asteroids and comets. We can study each one of those and they all have something they can tell us about how the solar system formed or how Earth ended up in its special place. And understanding why the other planets are different from Earth actually helps us better understand how we ended up the way we are today. So this is a globe of Mars right here, and many of the reasons why we're so interested in Mars, there's a lot of different processes going on Mars that help us better understand Earth. A lot of the surface of Mars has been preserved for almost 4 billion years, and so we can study a lot of things on Mars that you can't even find on Earth.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
So Perseverance rover is going to drive around and find some of the best rocks it can, drill down into the rock and soil and collect those samples so that on our next mission, Mars Sample Return, we'll be able to bring those back and study them in our laboratories here on Earth. There is volcano on Mars. In fact, there's lots of volcanoes on Mars. The largest volcano we know of in our whole solar system is on Mars. It's called Olympus Mons, and it is so giant that the entire chain of Hawaiian Islands could fit inside the crater at the top of that volcano. We see volcanoes really across the solar system on all of our rocky bodies. So on Mercury, we see evidence of lava flows on the surface of Mercury. Even on the moon, we have lava flows that we can see. On Venus, we see the entire surface of Venus is covered with lots of volcanoes and volcanic deposits. So this is a globe of the moon Io. Io is the moon of Jupiter. That's the most volcanically active body in our solar system. And that's because the pull of Jupiter's gravity on Io as it goes around Jupiter tugs and pulls at Io, and that heats up the inside and that drives volcanoes. The heat needs to be released. This is the volcano Pele. And there's lava flows down here in the middle, but then there's also this big red-orange deposit, which is actually from explosive eruption of the gases that are falling down onto the surface of Io around the volcano. And it has no atmosphere, so if you were to turn it like this and look at this volcano from the side, you see a big umbrella of gas. The particles just come out and then they drop back down. And I started studying volcanoes on Earth about 35 years ago, and then started studying volcanoes on other planets, and that grew into my love of our solar system. So the asteroid belt really contains a lot of leftover material from solar system formation. You can imagine that when the solar system first formed, the particles kind of came together and made bigger particles. Some of those came together and created the planets. We actually find asteroids in lots of different parts of our solar system. We have asteroids that are near Jupiter, the Lucy mission, which is going to launch this year in 2021, and it's going to go study those special asteroids that are trapped in Jupiter's orbit. And then next year we have another mission called Psyche that's going to a particular asteroid called Psyche. It looks to be made mostly of metal, of iron. It may actually be the exposed core of a small planet that may have had its crust blown off by an impact and left that metal core that we can see. There is definitely water on the moon. We know this because we've observed with some of our orbiters being able to identify that there's water molecules on the moon. And in fact, some of these we believe are preserved as water ice, perhaps in these permanently shadowed regions that are very, very cold near the poles. And what we need to do next is to actually go down to the surface of the moon and actually look at that ice up close. And so that's what we're doing with the Artemis mission. We'll be focused on looking for some of that water in the soil of the moon. We have explored really the far reaches of our solar system. We have sent missions to Mercury near the sun and visited all of the planets in our solar system, all the way out even to Pluto. And then one of our missions called Voyager actually has 2 spacecraft that have now even gone beyond the edges of our solar system. So we have really explored the whole expanse of our solar system.
Cool. Io and Mars are great.
Let's try it again. Oh, that's too high.
That was a fastball. She had a fastball.
Do you have a question for NASA? Send your questions to our experts using hashtag AskNASA. For more episodes of Ask NASA, click the playlist.